All right, let's take a look at this inequality, which is a rational function that has a logarithm in it. Got a lot going on here, right? So let's break it down. Okay, well, we have two things we always want to look for in inequalities. We're trying to figure out where it changes from being negative to positive or where it might change, right? And so we're going to look at these two cases where f of x equals 0 and also where f of x is dne. Okay, so let's start with the easiest part, right? X squared minus 9 equal to 0. Well, that's going to give me x is equal to plus or minus 3. And then the harder one to see is where log of x plus 5 equals 0, right? So we got two answers here, and we'll be putting that on a number line in a second. As you can see, this one's going to have kind of a lot going on, so you want to organize your work on a number line to make sure you can solve it properly. So we got, this is really log of x plus 5 equals 0. We need to convert, this is really base 10, right? So we need to convert to exponential, which means 10 goes over here, 0 becomes the exponent. All right, well, anything to the 0 power is just equal to 1. Let's rewrite that so it looks a little better. Anything to the 0 power is equal to 1. So that means x plus 5 equals 1, so x equals negative 4. So now we have another solution here. Okay, now let's look at the dne, right? Well, before you go right to the denominator, you got to remember one thing. Inside of a parentheses of a logarithm, that can't be negative because it's the inverse of e to the x, and e to the x is always positive. So you can't get a negative inside of here when we're talking about inverse. So the first thing we need to say is that x plus 5 is greater than 0. So that means that x has to be greater than negative 5. Okay, so that one's, anything less than negative 5 we're not going to consider because the function doesn't exist there. Okay, and then after that we just got to solve this quadratic. And these are going to be values where x cannot equal 0. And that's because it would give you either a hole in the graph or a vertical asymptote. So we got two things here. We got x equals negative 6 and x equals 3. So x equals negative 6, that actually is not going to matter, right? Because we know that x has to be greater than negative 5. So actually, this is all dne here, right? This is all does not exist. Function doesn't exist, so we don't need to worry about if it's negative or positive because it's non-existent there. Okay, then we got x equals negative 4. We got x equals, well, these should be does not equal. We got x equals negative 3. And notice we got plus or minus 3, but this, the dne is always going to, that's going to be the value you want to recognize. And what's happening is you have 0 over 0, right? When you input that, you get 0 over 0, and that means there's a hole in the graph at that point. Okay, so now we're ready to input numbers, right? But that's a little bit difficult when you're looking at this whole thing. So let's look at it in the factored form, because really, this function would be x plus 3, x minus 3, times log of x plus 5, and in the bottom you have x plus 6, x minus 3. Now notice, because there's this hole in the graph, we can go ahead and cancel it out. There's no need to put it in because whatever, or input numbers here when you're testing, because whatever's happening here, right, it's going to get canceled out by itself, right? So let's input numbers now and we'll figure this out. If we input negative 4.5, negative 3.5, and here definitely want to input 0. Anytime you can input an easy number like that, definitely want to do it. And here I can overestimate, but anything greater than 3 will work. Okay, now the hardest one to see is the negative 4.5 because really that means you have log of negative 0.5, right? Or not negative 0.5, it would be positive 0.5. Well, what that means is that that part is going to be negative. So we're just going to kind of make a little tally here. That's going to be negative. That's going to be negative. So negative times negative will give you a positive. And then down here, you would have positive. So that means right here is going to be positive. Okay, and then let's actually backtrack here. Let's get rid of those. So now I know that's positive. Now let's put in negative 3.5. Well, that's going to be negative here. And now this is going to be 1.5. So that's fine. That means this is going to be positive. So we got a negative multiplied by a positive, right? And then we have over a positive. Okay, so if we're looking at this, we have negative, positive, and then positive here. So that means our net result is negative. Okay, so we're going to erase this just to make this a little easier. Okay, and then putting in zero is pretty easy. It's going to be positive all around. So that means we got positive here. And then if you input 4, it will also be positive the whole time. So if we look here, let's go back to our original problem. We're looking for where f of x is greater than or equal to 0. Okay, so f of x greater than or equal to 0. Okay, so that means we're going to include any zeros, but we're not going to include any d and e's. So that means we're going to have parentheses, -5, -4 is going to get a bracket, and then we're going to have -3 here. That's going to get included. So we have -3, and then we have 3, and then we have 3 to infinity. Okay, notice we're not including the 3 because that is a vertical asymptote. So now we've finished this problem, and this is going to be your final answer on this one for solving inequality that has a lot of parts, but once you break it down, it's totally doable.